Okay, so I need to get into character. Here we go. Here we go. I'm beyond excitement to introduce Dr. Connor Matthews Shorten to his own podcast today, the Weaviate podcast. But we're going to talk about something very exciting. But before we do that, congratulations, because as people heard from the introduction, you're now officially a doctor. So well done. And we're going to talk about something super exciting. And normally, of course, you interview people on the podcast, but you've been driving the work behind this. So it makes more sense, of course, to interview you about what you've been working on. And by way of introduction, before I'll hand it to you, is we, of course, seen a lot of opportunity with vector databases and large language models where people generate something and they want to store that back into the database to search through. And we've kind of, call that like generative feedback loops. And I would love to get a little bit of your understanding, Connor, as an introduction to everybody watching. What are generative feedback loops?
Yeah, thanks so much, Bob, for the introduction and for having me on the podcast.
For having you on your own podcast, yeah.
But yeah, I guess for everyone listening, we have a great tour of concepts to explain this generative feedback loop thing. And I think kind of a great tour would be to kind of do like how, they have that like levels of abstraction, explain it to me like I'm 5, then I'm in high school, college, technical expert. And so I'd say kind of the introduction thing is about how we are prompting language models by putting your custom data into the prompt. So you ask it a question like, what's Bob's favorite flavor of ice cream? And then instead of just having the language model rely on the knowledge it's learned from language modeling the internet, you retrieve information about Bob, and then this is the prompt that goes to the language model. So that's been kind of the foundation of this. This kind of like retrieval-augmented generation has been huge. And so now what we're looking at is firstly, just continuing to explore that, all sorts of data sources that you can prompt, and like how are we going to be mixing these prompts and having these local memories. There's so much innovation happening in that. We've seen all these tools like LangChain, Llama Index, AutoGPT, Weaviate. Yeah, I could just go on and on about all these things in Bob's Light. And so, so maybe let me pass it back to you, Bob. Doing kind of the highest level description of generative feedback loops, how would you kind of summarize it quickly?
Yeah, so it's very much aligned also with what you were saying. So how I see it is that the first thing that we saw, the opportunity with vector databases, if you purely look at text now, so let's park other media types, purely text, that we saw that we could actually change something that we had not stored in the database, we could use it on query time. So the example we've always been using, or at least I've always been using, was if I store the data object, the Eiffel Tower is in Paris, we could retrieve that by searching for landmarks in France. And that was always, so if we have like the document, the database itself, where that data object is stored, then we had like on query time this new opportunity with vector databases. But with generative search, I see it as like we're now also doing something with the output. So we can say, show me landmarks in France and represent them as if they were a Facebook ad. Mm-hmm. So it takes out the data object and it then generates something from that. And that can be interesting in itself, but I think it even becomes more interesting. And that's also something, of course, you're going to also show us in a bit, that we loop that back into the database. Because the exciting thing about this is, in my opinion, is that we now can store information back in the database, that we can vectorize again, that was not stored, that was not in the original data set. And I have a question for you. So one thing that people often, one critique that people sometimes have from these generative models is, of course, the hallucination. So, I mean, if it's correct, it's amazing. But sometimes if it's wrong, then it's like, well, less than amazing. And sometimes people argue that this prompt injection, basically, so that we get the data object from the vector database and we inject it in the model, that's a way to overcoming hallucination, or a way for people to inject data in the model where, on data that it can't be trained on, or that it wasn't trained on. And what I mean with can't be trained on, I mean, because of course, technically speaking, you could train on everything, but maybe like legal documents or something that you have, it might be difficult to just throw that in the open to be trained on. I'm curious how you see that. Would it be fair to say that this is a way in helping to overcome a hallucination, or would that be a stretch?
Yeah, and it's such an interesting topic, is the hallucination. When you do the prompt injection, is it going to hallucinate? And so I'd firstly point people to a couple of resources that I'm then going to summarize. But John Schulman did a talk at UC Berkeley on that's the latest update on reinforcement learning from human feedback about reducing hallucination with that optimization strategy. Can't recommend that enough. I was also at Haystack last week, and Colin Nesh did this awesome overview of all these generative feedback, hallucination, the cases of how it occurs. And yeah, it's so interesting. I mean, I think, you can, there's obviously the prompting thing where you just kind of tell it, please don't make anything up, right? Just explicitly say that.
Yeah.
And then I really like kind of ideas around like the natural language inference thing, where you have the context and the generated, and you're using these models that classify entailment or contradiction. I think that's a potentially promising way to, filter it out. But it does, from the start, I might be going a bit off, but I had this conversation with Nathan Lampert from Hugging Face about this kind of thing, where I was like, how great would it be if the RLHF objective was don't hallucinate directly, not just be useful, but you could just make it like that. And so I think I think the optimization task will figure that out. Yeah. What do you
Can you talk? Yeah, can you talk a little bit more about that? So what would that look like? How might that potentially work? What are the ideas there? How's that?
Yeah, so right now the general thing is like, did you enjoy this answer? Right, like that's the signal, and it's reinforcement learning trained. I think and to maybe do the ELI5 thing, like these aren't quite language models anymore. They're pre-trained by predicting the masked out tokens, but now they're fine-tuned with reinforcement learning. And the key difference there is that in reinforcement learning, you make several decisions and then receive a sparse reward. So the language model, each token it generates is like a decision, and with the masked language modeling, it receives feedback for each decision because there's like truth to it. But whereas with the reinforcement learning, you generate 400 tokens and then receive the reward. So if you just change that objective to, did you generally enjoy this answer, to, did you hallucinate anything from the context, and you annotate a large enough data set, I think it's extremely likely that helps a lot. And yeah, it's such an interesting thing how I love those pictures where it's like, it's explaining the language model where it's like this giant monster and then there's like a mask on the front of it.
Exactly. I think that's interesting that you're saying that, because the to stay with that metaphor, it's the of the monster, right? So the how I personally think about that sometimes is like when we look at like doing prompt injection through the database, is that we basically can say we want to use the generative LLM for its language understanding, but we don't want it for its knowledge. And I have a practical example, and to stay with the monster example, it's like the monster is probably very strong and very big, so we want it for its muscles and we want it for its strength, but we just want it to do what we want, basically. So the example that I sometimes give is that for a simple, so to stick with that Eiffel Towers in Paris example, that you might store a document in the database that you vectorize that says something like, the Eiffel Tower always has been in Paris, but it's moved by truck to Barcelona. Making this up, right? And so you could vectorize that and you could store that. So now if you have the query, where's the Eiffel Tower, it will return that document first that says that it's moved to Barcelona. You can you can loop that into the LLM and say like, okay, where's the Eiffel Tower? We'll try to get the question, where's the Eiffel Tower answered, but you must base it on the information we're giving you right now. Mm-hmm. And then the LLM responds like, okay, maybe something like, hey, it was always in Paris, but now it's moved to Barcelona by truck, something like that. And that is kind of where we want to get, so that we use it for its language understanding, but not per se for the knowledge. And it's interesting, so the experiments we see with, like, the role of the temperature and those kind of things in the those kind of settings in figuring that out. But I think it's super interesting. But before we dive into an example, so could you, because now we've went from the query to like the database to like output, what would can you explain, like, to listeners what the feedback loop would be? So how would the feedback loop be closed, basically? What's happening after the information comes out of the generative LLM?
Yeah, amazing. And so I think that was a quick introduction to the Retrieval-Augmented Generation. And so now, we're taking the next step where we're talking about the title of the podcast, the Generative Feedback Loops, which is where, so we're going to take the data and we're going to generate something and we're going to save it to the database, because then we can access that for future generations. We can search through that. We want to save it. It's like our data that we're using. So yeah, I hopefully think that the example I kind of like this example. So why don't we dive in?
Yeah, let's go.
Hey everyone, welcome to the Weaviate Generative Feedback Loop tutorial using a data set of Airbnb listings. We're going to be illustrating the concept of generative feedback loops, where we take data from the vector database to inject into the prompt of a large language model, and then we'll save the resulting generation back into the database to use for future prompt injections, or generally whatever we might want to do with this generated data. Say it's a summary of a podcast, or in this case, a description of an Airbnb listing. So let's dive right into it. So firstly, all the code for this can be found in Weaviate/generative feedback loops. In addition to this Python notebook, we also have TypeScript examples of how to do this. So firstly, we'll install the Weaviate client with pip install Weaviate client. And then as a bonus part of this, we're going to be showing Weaviate embedded. So Weaviate has recently released Weaviate embedded, where you no longer need to stand up a server to connect to Weaviate. You can now run this right inside of your Jupyter notebook, which is super convenient for Python developers looking to quickly get a sense of how to use Weaviate before necessarily, say, putting a database into production and all that kind of stuff. So one other quick detail is, in this tutorial, we'll be using the OpenAI large language models. You can also use the Cohere language models, and this repository will also contain a notebook with the Cohere generations as well. So if at any point you want to see which modules are running on your Weaviate instance, you can just do the client.get meta, and you'll see the enabled modules and links to the documentation of where to learn more about them. So the embedded module is going to come with default these kind of generative search, OpenAI, the text-to-vec, Hugging Face, and all these kind of things. So first we're going to be loading our Airbnb data. So this is a CSV file of Airbnb listings that we found on Kaggle. And so, pretty standard Python stuff to, use the pandas library to read the CSV, replace, null or infinite or nan values, and then just convert it to a list of dictionaries. So with this list of dictionaries, the first entry, we have these keys for different values, the ID of the property, the name, a quick description of it is name, and then, you got the host name, who's hosting this Airbnb, what neighborhood it is, more particularly. So Kensington is a particular neighborhood of Brooklyn, and then, other things about Airbnbs, like what type of room it is, the price. You can imagine all these features, like, does it have a pool, all that, bedrooms, bathrooms, square feet, all these kind of features that describe an Airbnb. So here's the first thing that is so interesting to me, is that as of right now, it would be very hard to just take these kind of tabular symbolic features and pipeline that into semantic search. I used to have this recommendation that the best way to do this would be to do some kind of tabular to text translation, where you have like feature name equals feature value, in the next feature. So it'd be like ID equals 2539, name equals clean and quiet, sorry, apartment, home by the park. And so that would be the text string that you would embed and try to search with. But what you're going to see with generative feedback loops is we're going to sync this up into a written description that contains all this information. And then by putting it back into the vector search database, you can search through the different Airbnbs in a much more natural way using semantic search. So let's continue on the kind of how do you do this with Weaviate. So this is how you create schemas in Weaviate using the Python client particularly. So you open up the classes, because Weaviate has a class schema where classes are like tables in a database, where you could define more than one class basically, and you can link the classes to each other with cross references, which is, similar to like how most database systems have like a key adjoining system. So we define the class as listing, we give a short description of the class, and then we're going to be configuring the modules to use on this class. So the module configuration particularly is that you set in the schema is the vectorizer. So say this is going to be vectorized with ref to vec, or that kind of thing, but this is going to be vectorized with the text to vec OpenAI embedding model. So then you just kind of tell it which properties you want to vectorize with the skip parameter on each individual property, but we'll get into that. So so vector index type, we're going to be using HNSW for this, and then the vectorizer is what we define in the module config. So then what we have is we define a list of properties, with each property being like a attribute of the database table. So this is our description. This is what we're going to be generating and saving into. This is the the description of the apartment listing that will be written by the large language model, the product of our generative feedback loop. So then we have all these other features that we use to describe the Airbnb. So you can also see how we have a mix of text features as well as number features. And please ignore that this is written as string, because this should say text. But anyways, cool. So then at the end of this, we create the schema like this, and then we're going to be importing the data into Weaviate. So we're just going to be looping through that data list that we had imported with our our pandas read CSV, then df to records, save that in this data list. So we configure the batch imports, then we just loop through this. We're only going to do the first 100, and we just copy the keys, get the valid UUID, because this is a database, and then we just add it to the batch, and it puts it into Weaviate. All right, so now that our data is in Weaviate, we can do a simple get query. This is the client syntax. So maybe listeners out there have seen the Weaviate GraphQL console, and you've seen these GraphQL queries, but each of the clients, they also have kind of a querying language like this. So you do client.query.get listing, and then the property that you want to have, and then you can append on these filters like dot with near text, or like dot with hybrid, dot with limit, dot with where. So that's kind of like what this syntax looks like with the Python client. Cool. So then we're going to add another class, which is going to be our advertisements. So we're going to be, from the descriptions, writing advertisements, and then generative feedback loop, saving that back in the database. So we also create, so this is how you create another schema to add to the database, to add to Weaviate. And then we're going to add another property with this cross-reference from Airbnb listing to advertisement, and the named references has add. So we just use this to create that new property from listing to the advertisement. So now the most exciting part of our tutorial, we're going to be generating the description, the Airbnb description. So what we do is we have this syntax where we have these curly brackets, which is where we put in the property value. So with each of these prompts that go into the language model, you'll replace the curly brackets with whatever the feature value is. And this is how you prompt it to the language model. So this is kind of what I was talking about earlier, where you would represent your data with some way like this to search through, instead of doing this generated thing, which is, I think, a really exciting way to unify the most of the data, which is tabular organized data, with this new semantic search technology. But so here's more into the syntax. So we have these generate properties that we pipe in by doing client.query.get listing, generate properties with generate. We give it our prompt, and then we also give it, so we already gave it the properties within here, because it's already a list. So usually it'd be like a list with the properties. So cool. So we also get the ID out, because we're going to need to take this ID in order to add this new property back to its source. So by taking the ID, we can then key value the ID to the new description. So then we loop through these descriptions. We have the new property, which is the dictionary of what we're going to be updating. So then we take that ID out from the underscore additional ID, which we got from here. And then we do client.dataObject.update, the new property, the class name, and then this ID that the description was sourced from. So now we're going to see our resulting generated description. So first we're going to insert description back into this generate properties, as we use this syntax of class name and then the properties you want to see. So we'll just see the first one. So we take all these properties from the availability of the room, the neighborhood it's in, the short description of it, the price of it, and we write this, and the large language model writes this description. This private room is located in the Flatbush neighborhood of Brooklyn, offering a unique country space in the heart of the city with a price of $150 per night, so on. So I think you get the idea. But like, so this is the generated description that we've saved back into the database. So now let's say we want to query the description. So we .get listing description is what we're searching, what we want to return, and then .with near text. So this is how we do our vector search, with concepts being the name of the argument, and then Airbnb near a place to walk my dog. So what this means is we're going to take this phrase, Airbnb near a place to walk my dog, transform that into a vector that captures the semantics of this sentence or this phrase, and then we're going to search for the semantic similarity between this and then all of the generated descriptions we've done for all of the Airbnb listings to try to find you the best place to walk your dog. So you see the result of that and how that lets you search through these Airbnbs with queries like, 2 bedrooms, hot tub, or just whatever kind of casual language you want to use to describe the ideal Airbnb for you. And in the future, we can imagine all sorts of things from images and videos and just kind of the mind-blowing implications of this kind of technology as it continues to develop. So now let's keep generating stuff. Now let's generate an advertisement. So the prompt is now going to be, please write an engaging advertisement for the following Airbnb listing, description, and then we're going to pipe, again, generative feedback loop. We're going to take that data that we saved in the database and we're going to send it again as input to the large language model. And then we're going to, again, save that result back to the database. So again, this is how we do our generate query, visualize the first ad. And then again, we're going to loop through the ads and we're going to take that. In this case, we're creating novel ad objects, so we don't need the referencing ID. Oh, we need the referencing ID for the cross-reference. So we'll generate a random UUID for the advertisement object, but then we'll keep the UUID, which was the source of the description that generated this ad, to use to link to this ad with the cross-reference between the classes or tables, if you want to think about it that way. So now we'll be looking at a quick thing of how to use this cross-reference syntax when you're querying Weaviate. So first, we're going to set this where filter on the path. So we're searching through the Airbnb listings, and we're going to add this filter where the listing has greater than or equal to 1 advertisement. And then we're going to see the description of the listing, and then has ad, and then now the cross-reference takes us to the referenced ad, and then now that we're in the ad class, similarly to this, we take the content property out of it. So we see how the description, this private room is located in the Flatbush neighborhood of Brooklyn, and then we have the advertisement, and the advertisement is, escape the hustle and bustle of the city and step into your own private country oasis in the heart of Brooklyn's Flatbush neighborhood. So we see how we use this description that we originally had generated and saved in our database, and now we're going to put that into the language model and then feed it back into the database now with this advertisement. So now let's go into targeting advertisements. So first we can imagine some generic ad targeting. We add a text property target and we add that property to our database on the ads. And now we have these targets, say young couples, elderly couples, single travelers. And the generate prompt then becomes, please write an engaging advertisement for the following Airbnb listing, description, and then we prompt inject the description. And then please write the advertisement for this listing to target, and then the target, which is another property that we now have, but in this case I just put it in this list, but you could retrieve it however you want to do it. So similarly, we generate it. We use the UUID to then link the new advertisement to the referencing the referencee or the referencer listing. So then we're going to look at this, a single traveler. So this ad writes, attention all solo travelers. Are you looking for a cozy and affordable place to stay in the heart of Brooklyn? And then, make your solo trip to Brooklyn unforgettable. Things like this. So now let's kind of think a little more about all the different data sources that we can grab from to prompt these language models to write more targeted advertisements for these listings, or maybe even advertisement, because advertisements sound so kind of like spammy in the past, but now what we're seeing is customized descriptions for you. So it's not written just to be salesy, but it's written to tailor to your interests. And hopefully this will be more clear as we look at it a bit more. So now we're going to add another class to the database, user. And then in the user, we're going to have a biography for the user and the person's name. So we have 2 users in our database, Connor. Connor often travels with a golden doodle named Bowen, and Bob. Bob is a prolific weightlifter who will get upset if he doesn't have a good gym to work out in. So now what we're going to be doing is we import our users into the database and we see that they're in there. We're going to add a user target for the advertisement. So each advertisement that we write a user target ad for, we're going to add a cross-reference for that. And the interesting thing about that is that we might not want to write one for all of the users. We might want to be clever with the way we do it and things like that. So cool. So now we change the prompt to similarly to how we had that generic target. Now we're going to have the target the following user, and then we're going to pass in the user biography that we had used by doing users equals client.query.get user biography with additional ID, because we're going to need this to do the cross-reference later, and then we get the data this way. So now, after we've added all the data, we query it, and we'll see some of our resulting advertisements. Attention all weightlifters. Are you planning a trip to New York City and need a place to stay that won't compromise your workout routine? So that's an advertisement for Bob. And then for Connor, you have, attention all pet lovers. Are you looking for a pet-friendly accommodation in the heart of New York City? Look no further than the village of Harlem. So you can see how, I hope that from this you can start to get a sense of all the things that we can do with this kind of idea of generative feedback loops, all the different data sources we can use, the kind of compounding effect of saving this data back into the database. And so with that said, let's jump back into the podcast.
Oh, that was very interesting to see that Airbnb example, Connor, and that makes a lot of sense. So just to quickly recap, what we're basically seeing here is that we're adding a data set without any descriptions to the database, but because we generate the description and feedback loop that in, it creates a vector representation, and now we can do semantic search over these descriptions. That is correct, right?
Yeah, and so I would love to start on that example of now you have something you can search through. And so to tell a quick story, when I was when I gave the talk at ODSC London last year, I was I was trying to think about presenting vector search for data scientists, people who are doing analytical queries with mostly like tabular symbolic data. And, they're thinking, how do I use semantic search on this kind of data? And my advice for that used to be, maybe you could translate it to text by just prompting it with like feature name equals value, and so on. But now what we just saw with the Airbnb is it took all these properties from price, minimum nights you have to stay at the Airbnb, what neighborhood it's in, and it synced it up into a description that now you have something that you can search with text. And so I think that angle of turning tabular data, unlocking that with semantic search by putting it into the generative model and producing this kind of thing, that is one of my favorite artifacts of the example. But something I really want to dive into next, Bob, is this just this concept of, Bob is a gym rat and he's always got to be in the gym.
No, but that is exciting, right? Because we're getting to a situation where where we're just getting to real time personalization of data, which is just, if you think about it, it's like with the first generation of for example, reading newspapers, we had, the newspaper was a day old. That's now through the internet became real time. But we're now getting to a situation where it gets optimized. Something that I'm in line with is what I'm excited about is the, you could even go, let's say that you have a news article, right? And there might be, you gave earlier during the podcast, you said explain to me like I'm 5-year-old explain it to me like I'm an expert. So a journalist could write something only focusing on experts, but then real time, if somebody says like, hey, I'm an expert on the topic of finance, but I'm a noob on the topic of politics, for example, then a certain thing that's in the political in the financial section of the newspaper could be specific for this person, very into depth. But when this person goes to the political section, you could just say, okay, we just made it significantly easier, and we only, we simplified it, and that's all happening real time. And that is something that is, I think, extremely, extremely exciting. Are there so besides the example of Airbnb, are there other examples that come to mind that you can think of?
Yeah, well,
for use case?
Yeah, I think Well, I love what you just said. That idea of the education personalization. Like last night, I was playing with the TypeScript client, and I don't even know the difference between like npm and yarn. So it's like, I have this particular kind of knowledge, but I'm missing this plug, and you have all this data about me. Imagine, having just like every Medium article I've written, maybe every Slack message, all this thing to kind of build up this embedding of my knowledge and then pass it in and customize it. I love that angle to how you present things. But yeah, so I guess diving into another example, to stay on the Airbnb. One more thing, I just love this idea of like of the personalized travel experience, and just how, like when I travel, I generally travel with my dog, and so like I need to plan my trip to New York accordingly, and the things I want to do, say if I'm staying a weekend, are going to be different. So yeah, I think if we could even go into the sci-fi almost, and you shared this a tweet this morning about something that is this generate TV shows personalized to you. How are you thinking about this?
Yeah, so so actually there was actually just before we recorded this podcast, I was discussing, and maybe we can just cut a little piece of that video in the in right now. So what we just seen in this video is that a video was rendered based on just 100% coming from these generative models, and everything we're talking about right now, the use cases are based on text. So I had the Airbnb example is very practical. That is something people can start, using today. But I think where this will grow into is like we see a lot of models evolve, not only for text but also multimodal models and images and those kind of things. So what we're seeing here is this, and this is also why I'm so excited to work on a vector database,
Mm-hmm.
right? So where we store information, for example, about a movie, and interest about people, how people like to see movies and those kind of things. So now you can say, okay, render this part for me as if it's, well, as we've seen a Wes Anderson movie, or render this part is like it's part of the Matrix. Like we said with the news articles, you can say like, hey, if you are very much into I don't know, costume dramas, that you can say, okay, just make this longer, or really go more into depth on the in the storyline. Or if you hate costume dramas, like just make this a short thing, right? And the if that's in a movie. So the point that I'm trying to make is like with everything that's happening right now, with how the technology is evolving, I would not be surprised that in I don't know, a few years from now, we will watch the first a movie or series or whatever, and it might start with just 5 minutes or just 10 minutes, where we're watching something that is completely generated, and that the real-time generation is good enough, or that it can just pre-process something for somebody like in half an hour, and that that Netflix says like, okay, your next episode is ready, right? We
Yeah.
pre-process it for you. I would be absolutely, could see this happening. And think about like if you think about also things like AutoCAD and those kind of things, where it generates drawings, where it helps you with those kind of things. You could feed it information about, like, if you have a certain building, about like the history of the country, about the city that you're building in, maybe the type of soil you're building on, and it just takes all that information in. So yes, text is the first iteration over this, but with everything that's happening, and I think this video is a nice example of that. This is just going to be a matter of time. And it's amazing that, of course, besides the machine learning models, that in that core infrastructure, database like Weaviate plays a role in that. So that's something I'm super excited about. So that's how I look at it.
Yeah, I love how you're telling the story of kind of the evolution of search, and I think for our listeners, it like can't be emphasized enough, sort of how novel this image search is, this multimodal search, because I think kind of in this context with text search, you had you had these things where you had keyword matching and you have an inverted index and you had all these tools built around that. You had symbolic features, like you had the PageRank algorithm for Google where you use hyperlinks to get features about web pages and kind of search with that. But this kind of way of representing images, videos, audios, or, the CAD drawings that Bob's explaining with, when you have 3D structures of building designs, like being able to put these all in vectors and then unify all of this kind of data from different modalities into one kind of space where you can put an image to query for a song potentially, or like all these kind of things. And yes, the AI movie thing, it's so interesting to me. I've been listening to a lot of AI hip hop music lately, and I don't think we can play this. If we cut and then play that, I think I think we'll be in trouble. I think for our next podcast, we'll need a lawyer with the.
Yeah, exactly. Yeah. So it's like let's keep it out for now. No, but people can imagine. People can hallucinate what that might be like. Yeah. So no, but it's funny. It's like actually there's a not to go too far off topic, but it is related. There's an author that I'm a big fan of. His name is Bruce Sterling, and I believe he calls himself a fictional design writer or something like that. That is based on a concept that is called speculative design. So it's like a big problem that we have with thinking about these concepts of where things going is that as the late Clay Christensen always said so nice, he's the Harvard professor Clay Christensen said like the future is beautiful, it just has one problem, it has no data. So it's like we can't predict anything, right, because on the future. So what speculative design does is that it's a methodology to try to determine potential futures. And one of the things that Bruce Sterling says is that often you see these innovations, these technical innovations, and the impact that they have first in music. So the hip hop example that you gave is a good example, right? So it's there's a lot of abstraction in music. So I mean, I know of people using generative AI in music for a long time already, and of course it was way more. The capabilities were way simpler, so it was very abstract music. But you could already start to see where this was going, and very early on. So he makes a beautiful argument that he says like, hey, if you want to know what's happening, what technology is causing, just look at music first, because if it's changing in the music industry, then it will probably trickle into other industries or in this case art forms early on as well. So it's an interesting example. We should make sure to link to these articles in the podcast as well. Yeah. I mean, in the description of the podcast.
Yeah. The speculative design, all that kind of like mental models of thinking, that all that is so interesting. And I think even just one more thing on the music is it really explains the vector database kind of part. Like, let's imagine we have these brain computer interfaces that know so much about the kind of music that I like compared to the kind of music that Bob likes. And these kind of like brain signals, you can represent them with vectors, with models that to vectors, to audio, and sync it all up. And yeah, it's a pretty exciting future. And yeah, maybe one more thing is, you mentioned speculative design theory, and I always find it personally very interesting, like learning these things from you. You taught me like the jobs to be done framework, and the most recent one you taught me in the context of this generative feedback loops project has been aggregation theory. Can you explain what that's about?
Yeah, so aggregation theory is a concept from a guy named Ben Thompson, and he has this nice blog which is it's called Stratechery. So not strategy, but stratechery, and that's his that's his job. and he just tries to capture what's happening in or the impact that the tech industry is having on the world, basically, right? Especially from a business perspective. And of course, in my role at the company at Weaviate, I'm very interested in this, right? So what we're talking about today is super interesting, and that is super exciting. However, it's important that we keep in mind, like, how does this add value into people's lives, and then out of that comes like how people use it and those kind of things. And one of the things that he describes in this framework is that before it's based on the internet. So and the role of that distribution channels have, and the control that they have. So, for example, think about a traditional newspaper. The distribution was very important because to get a newspaper, it needed to be distributed. So there was a whole role for the distribution channel. So the first iteration of that was like, because the distribution channel was gone, because it was just on the internet, there were like other outlets and other way to get information to people. And that is what aggregation theory describes and what the impact on business. But I believe that what we now see with these generative search cases is that we're just going into like a next step into this, right? So they were basically saying like it's becoming, for lack of a better term, it's becoming hyper personalized. It's like I currently cannot think of a way to make it more personalized than this, because if you have the right information. So the example that you gave, that you like to travel with your dog. That is, if you then can say, hey, I need to go to New York, and we know what kind of apartments you like, how much money you like to spend, that you travel with your dog. That is so hyper personalized that it's like a based on that first observation of in aggregation theory, how basically the internet shook up these distribution channels. We have like this next generation where we're basically saying like, we're now basically shooking up these databases or these outlets where we have just this generic content for everybody, that we're going to say, no. Now the next iteration is like hyper personalize this. So I am to use your terminology, beyond excitement about that.
Well, I'm super excited. One of the two, yeah. But
exactly. I have one more question for you as well. So I'm curious to see the how are you observing? So the first big thing that we saw, where the opportunity for like the feedback loops and those kind of things had, that it became an area of interest for us. And bear in mind, for those listening, it is an area of interest for us because we try to figure out how can the vector database Weaviate play a role in this. I think the first thing that we saw was the ChatGPT plugins, right? Or am I missing something there? I'm just curious what your thoughts are on that, how that's evolving and what you're seeing there.
Yeah, that would be really great to talk about how this impacts with ChatGPT, and that generally the kind of idea of, the interfaces, the chat interfaces, and when you save the conversation history and then using that history, because, every conversation you have, it comes back. And I mean, let me ask you this question. How many conversations do you think you've had with ChatGPT so far? I would say for me, it's been at least 500 so far. And it's just like been 4 months old, something like that. So it's like,
yeah, so this is a great question. And I have to say, not only, if you don't mind me making the question a little bit broader, I'm willing to go on record to admit that my brain is still processing the fact that I'm using natural language to get something from a data store. So regardless if it's ChatGPT that I ask a question. So the other day I wanted to have something sorted, but then I had to go through information, and I was like, let's throw that into ChatGPT and see how it searches through it. Or the other day I had something where there was something stored in Weaviate, and that I used a very abstract a query to get the information out, and it gave me actually what I needed. And my mind is still blown. It's like still in state of being blown, right? It's like still happening. So I'm starting to have more and more interactions also with ChatGPT. But I think What's more important here is just that change in the world, that we're just going to a natural language way of interacting with our systems. That is for me just I don't know, I'm still parsing that basically.
Yeah. I am obsessed with this kind of text to SQL research, and then thinking about how that translates to Weaviate. And yeah, from like and I give a quick shout out to Jerry Liu at Llama Index, because he's done some awesome content on this kind of stuff. But let me this idea that when I interact with the database, I just say, show me an example of ref2vec that you searches through e-commerce images, and then the database, then it can parse out the query and know what filters to add to the database. Because I love this kind of filtered vector search thing, and saying like when we had Sam Bean on from U.com, and he described the kind of the idea of like a vertically integrated search engine. If you've seen like Perplexity AI, you've seen how you can, do you want to search through Reddit? Do you want to search through Twitter, Wikipedia? So then you have this filter, where equals Wikipedia. And it's so exciting because in terms of like the technical innovation behind Weaviate and vector databases, there's so much exciting stuff with like, modifying HNSW and routing these things to have the filtered connectivity. So yeah, that natural language interaction where you just ask a query and then it parses it, all that is so interesting. But yeah, and so pivoting topics a bit, coming back to the generative feedback loop thing, I think for me, the first time I started actually using this in my life for my work is I take these podcasts and I transcribe them with Whisper. And then I kick off a summarization of them, and so then I save this summarization of the podcast. So to me, that's like, that was the first thing when I just started like using it for my actual like productivity in my job. So yeah, let me ask you maybe like what do you think, like how are you using kind of generative feedback loops?
Yeah, so there are two answers to the well, there are probably multiple answers. Oh, let me think. That's a great question. So I think on the most holistic level, so the first one is what you've shown with the Airbnb example, to generate data that is not in the original data set. So where we always have been inferring insights, that we needed to have a human in the loop to infer some insight from a data set, that we don't have to do that anymore, that we can automate that away. That is something that I'm thinking about. We're talking here about these these descriptions for Airbnb, but this can be anything, right? This can be houses that's for sale online. It can be movie reviews. It can be, and then we're just talking about text, right? And so that it can be anything. It can be cybersecurity threats, right? So that if we have learned something in the past from complex cybersecurity threats, we can store that in the database, feed that into model, combined in the prompt. It's like, what do you think of X, Y, and Z? And then it gives us something, and we store it back, and now we can search through it, etc., etc. So that is the first one. The second one goes back to what was said earlier. That's that hyper personalization. So we could basically say like, hey, if we know that Connor is going to New York with his dog, and he's going to stay near Central Park, we can already start to generate content for, maybe, I don't know what you do with a dog, but take it to a dog salon or something. I don't know what you do with a dog, but it's like that you can say, hey, if that's something you're out of interest, you can go there. And if you say, yes, that's out of interest, then we can feedback loop that back in that you were actually interested in that. So in the future, then if you go somewhere else, if you go to LA with your dog, then we know et cetera, et cetera. So I would, on the highest level, I would say a combination of so generating insights from data that normally humans needed to infer from the data, and secondly, just that hyper personalization. In your opinion, did I miss something, or do you also see something else?
No, yeah, I think that hyper personalization. I mean, just like thinking about like business executives like you, like I can imagine like an LLM is like a virtual assistant for your scheduling, yeah, and the traveling thing, just keeping you organized by knowing about the particular things you like, and all that is so interesting. Yeah, it really brings me to kind of the headliner that I was really excited to at the end of the pod, because I wanted to, hopefully we kept it concrete enough in this beginning of, well, and it's as crazy as it is, this actually is pretty concrete. It's not something that's just purely hypothetical, but
No.
from ChatGPT, which I think captured everyone's imagination, it was like, whoa, what is this? Now we have Auto GPT, which is another like, oh my, what is this too? This is so much potential. So Auto GPT with Weaviate, it comes up with a plan to perform a task. It breaks it down into steps and it saves the intermediate steps back to the database. It has this, generative feedback. It could maybe be prompted to know that it can save its intermediate generations. What do you think? Auto GPT with Weaviate, where is this taking us?
Yeah, so exactly, exactly as I think as we mentioned, right? So what you're basically doing is that you're saying the data, the information that we're rendering, or pre-storing that information, because there is a Weaviate integration in AutoGPT, but that always starts empty. So it starts to its research and then stores that and vectorizes it, etc. But what if you would say, hey, we have data, we're going to store that in Weaviate, and then you use AutoGPT to find stuff. Just imagine what that means. And bear in mind, I always like to say 89% of data is behind closed doors. So let me give you an example. I spoke once to a lawyer, and this lawyer said, you know what the most used, and then I don't mean from a database perspective, but from a consumer perspective, what the most used tool is that lawyers use to find stuff when they're writing, documents or whatever. You know what the most used tool is? Google search. So, but the thing is, the power is that there's the human in the loop, that the human lawyer looks at the documents that they have internally. So the Word documents, the PDFs, whatever they have for whatever they're working on. So they have that context in their head, and then they use public Google or something to find something, and then adjust the documents accordingly to what they found. So what we're basically saying is, like, if we take these documents and we store them in Weaviate, then something like AutoGPT can basically just create those feedback loops based on that information. Hey, I'm looking at this part of the legal document, but I need to know X, Y, and Z. Let's find that online. We found something, vectorize it, store it back into Weaviate. So long story short, so that was the long answer. The short answer is that with these kind of systems, that what AutoGPT is and what it's going towards, that we're basically going to say, hey, if we pre-fill Weaviate with information about something that cannot be accessed to the public internet, then AutoGPT starts to function as a knowledge worker in which the database plays a tremendously important role, because that's where the information sits and is vectorized. So that's how I see that.
Yeah, it's amazing. I remember when when the ChatGPT API or the DaVinci 3 API was, when we were playing around with it initially, and we were exploring the kind of question decomposition where you have a question that has did Thomas Edison use a laptop? And then you need to break that into, okay, when did Thomas Edison live? When were laptops invented? And that kind of like, that kind of multi-hop question answer. Multi-hop is kind of the academic term for that kind of idea. So I remember when we were exploring that, you showed me this idea, and I have to always give you credit for this, because it was such like a whoa to me, that you were prompting it to populate a JSON dictionary with, if it wanted to ask another question, what were the results of the intermediate question. And I think that's the biggest idea in this kind of large language models that use tools, is that they write it in the API compatible way. They can output the JSON. They can see what you want to see it. And yeah, so it's so interesting, because like, if it knows how to write the data to Weaviate, all this kind of stuff.
Exactly. And that is something I am very curious 6 months from now, if we would revisit this conversation, where we are in and the role that these generative feedback loops play. It's going to be exciting, because we already see it, but we're now basically going to support it extra from the perspective of the database. So that's something I'm super excited about. So I think I think we're there, don't you think? Because I think it's for everybody listening. They need to check out your blog post and like the GitHub repo to start playing around with this, because this is not fiction. This is just people can do it right now. And I believe the Airbnb data set will be available as well, so that people can just play around with it. Is that in Python and TypeScript, I believe? Am I correct?
Yeah, Python and TypeScript. TypeScript was a new thing for me to learn, but it's really cool. Having to hover over it and see the types, it can definitely help you navigate a new JavaScript library. Yeah.
Fantastic. Well, thanks so much, Connor, for letting me interview you. How did I do? Did I do a decent job?
Yeah, awesome job. You got to ask everyone to like and okay. Thanks so much for watching. Please like and subscribe.
Oh shit, I forgot. Thanks so much. Bye.